Hi, I'm Mike Geraghty, and I'm going to be talking to you about amines. Amines are organic compounds deriving from ammonia in which one or more of the hydrogen atoms have been replaced by a carbon group. In these diagrams, the carbon groups are represented by the letter R. There are three types of amines. Primary amines have only one hydrogen that is replaced by a carbon group. Secondary amines have two hydrogens replaced by a carbon group, and tertiary amines have three hydrogens replaced by a carbon group. Amines make up amino acids. The first amino acid was discovered in 1806 in an asparagus plant. Research continued, and notably, research on amines in organisms began. In 1928, Miss M.L.C. Hare discovered tyramine, which is an amine in organisms. In the 1930s, breakthroughs occurred, and most of the information we know on amines that take place in organisms was discovered before World War II. Making amines is very complex. There are many methods, and each of them have more than one step. To make a primary amine, it takes at least two steps. First, ammonia reacts with a salt, like ethyl bromide, to form ethyl ammonium bromide. The ethyl ammonium bromide formed in the first step then reacts with excess ammonia in a reversal reaction, and the ammonia takes away one of the hydrogen ions and makes ammonium, and also takes away the bromide. The final product in a reaction like this is ethylamine, which is one of the simplest amines. Now we have a primary amine. To make a secondary amine, this primary amine re-enters a similar reaction. The ethylamine would react with ethyl bromide to form diethyl ammonium bromide. Then, like in the previous reaction, the diethyl ammonium bromide reacts with the excess ammonia in a reversal reaction. The ammonia takes away a hydrogen ion and the bromide. The product of this reaction is diethylamine. The diethylamine can enter a reaction again to make a tertiary amine. Amines have certain physical properties. Hydrogen bonding is very key to these properties in primary and secondary amines. Tertiary amines cannot hydrogen bond to themselves because all the hydrogens on the ammonia are taken up. In primary amines, the simpler they are, the lower their boiling point. Because of this, the simpler amines are gases, while the more complex are liquids because of the different boiling points. Amines smell awful. They are responsible for the dead fish smell. Amines are also less dense than water. Finally, they are colorless. Most of the unique chemical properties of amines are attributed to the lone pair of electrons left on the nitrogen atom. This makes amines bases, and most amines are stronger bases than just the regular ammonia. Amines will react with acids and also water because of the ammonia that makes up the amines. Amines are not flammable. Most reactions that amines take place in are reversible because ammonia is such a weak base. There are many ways to name amines. For example, there is the IUPAC method, which places the prefix amino to the regular name of the longest carbon chain in the molecule, preceded by the number of carbon on the chain that binds to the nitrogen. Another way to name it, the more common way, is to add a suffix amine to the name of the carbon group attached. For secondary amines, the prefix di is also added, and for tertiary amines, the prefix tri would also be added. For example, the simplest amine is an ammonia with one hydrogen replaced by CH3, which is called a methyl group. Therefore, the molecule is called methylamine or aminomethane in the IUPAC system. If two hydrogens have been replaced from the ammonia with methyl groups, the resulting molecule will be called dimethylamine. Some amines are given other names. and some chemists don't even know where they came from. Amines are more common than you think. 5 examples are methylamine, the simplest amine, nicotine, which is the addictive part of a cigarette, methamphetamine, which is a DEA-controlled substance, epinephrine, also known as adrenaline, and dopamine, which is a neurotransmitter that promotes happiness. As the building blocks for amino acids, amines are very common. They are used as neurotransmitters such as dopamine, hormones and histamines such as adrenaline. Some can take carbon dioxide out of the air. Some are used as drugs like methamphetamine, and some also are used to make dyes. Here is an example of a tertiary amine. You can see the nitrogen with its lone pair of electrons. Bound to the nitrogen are 3 groups of carbon. Any of these 3 groups of carbon could also be a hydrogen, but that would make it a primary or a secondary amine. Here is the ball and stick model that I made of methylamine, the simplest amine. The yellow balls are hydrogen, the black ball is carbon, and the blue ball is a nitrogen atom. Now we have the rest of the supercarbons. Alcohols are organic molecules with a hydroxyl group, or OH. They look like this. Alkyl halides are organic molecules in which one or more hydrogens of a hydrocarbon have been replaced by a halogen. Ethers are organic molecules in which 2 carbon atoms are linked by an oxygen atom, like here. Aldehydes have a carbon atom with a hydrogen atom and an oxygen atom with a double bond bound to it. Ketones have a carbonyl group, which is a carbon with a double bond between hydrocarbon portions. Carboxylic acids contain 1 or more carboxyl groups, which are COOH. Esters are formed by the removal of a molecule of water between OH group of an alcohol and the OH group of a carboxylic acid or phosphoric acid. Amines are organic molecules formed by replacing 1 or more of the hydrogen atoms of an ammonia molecule with a hydrocarbon group. Amides are organic molecules that have a carbonyl group attached to a nitrogen atom. Finally, polymers are organic molecules that are chains of monomers of all the other types of organic molecules.